Welcome to Cybersecurity from Scratch, Technical Foundations, Episode 12, Server Message Block, SMB. First, we'll talk about what SMB is and what the technical applications are. We'll discuss the history and why it has somewhat of a tarnished reputation. The next step is to look at how it's used by red teamers to enumerate a system, and how, once credentials are established, it can be used to move laterally within a system. SMB can also provide a covert communications pathway for red teamers, and so we'll talk about how this is used. And then finally, we'll talk about defense of this particular vector. At its most basic level, SMB is a client-server communication mechanism which is designed to facilitate several different functions. One of the biggest applications of SMB is for file sharing, tied into Active Directory over a Windows-based network. The operating system and Active Directory natively mediate access control for resources, so rather than needing to set up, for example, like a web server or something like that to distribute files across a network, it can be all done natively with the existing permissions that are defined for that network and for the network system resources. So if you see a resource name such as / hostname / resource name, this is an SMB access, and you're getting files over a network with this protocol. Samba is an open source implementation that allows Linux and Unix systems to access Windows shares, but it's all under the hood SMB. Another, more invisible use for SMB is inter-process communication. A particular process can open a named pipe on a particular system, which will allow other processes to connect to it. It's kind of the same idea as exchanging data over a TCP socket, but instead it's using this SMB service, and it's all tied directly into the security controls for Windows. So instead of, for example, opening a socket on port 8000, you can say, I'm creating my pipe, my service pipe, and then all information can be routed through that particular pipe. And this allows Windows to manage the security for that pipe so that you at the application layer don't have to add in additional services and whatnot. And so this can create a much more streamlined experience. Systems administrators will often use SMB because it allows them to execute commands against remote systems on their networks. The Windows sysinternal suite has a number of tools that use name pipes to issue commands. These features all sound great. So why does SMB have a bit of a bad reputation in some circles? The simple answer is that there have been a few high-profile exploits that have had absolutely catastrophic consequences. For example, in May of 2017, the WannaCry attack used Eternal Blue in a planet-wide strike that did immense damage worldwide. And this has just been one example. There have been several SMB vulnerabilities over the years, and given the nature of the protocol, when there's some sort of code execution vulnerability in there, the damage is catastrophic. Attackers are basically allowed full system control. Unfortunately, access points can also be misconfigured so that SMB leaks information. For example, if a user is allowed to log into a host with no username and password, then they might be able to access file shares and get other information about the system. If users have weak passwords, then sometimes SMB can be used to attack the system, and if credentials are compromised, then access can be gained in other parts of the system. Enum for Linux is a first-line tool used for enumerating SMB. Basically, the tool scrapes available information from SMB to try to find out workgroup, domain, if someone can log in without a username and password, and all that good stuff. So when you're doing an enumeration on a system, this is one of the first tools to use. Often systems will have unsecured SMB shares, either due to neglect or due to intent, and sometimes information is exposed on these that shouldn't be. SMB client can be used for both unauthenticated and authenticated sessions to gain access to these shares. First, it can be used to list the available shares, and then secondly, it can be used to spawn a basic prompt that will allow the user to get files, put files onto the system, and otherwise interact with it in a manner that's sort of similar to an FTP client. Now note, sometimes when you're interacting with SMB, particularly on some legacy CTF exercises, you do have to let your system know that SMB version 1 is okay. Now, this is something that can also be useful in engagements with late 20th century assets. However, it's also becoming increasingly rare to find these assets. If you see SMB available on a system and you're doing a CTF challenge, there's really two questions that you should ask. The first is there a vulnerability for this particular version? And often, if it's an easy system, you'll have a simple exploit that allows you to get system access. And if you don't have that vulnerability available, often the challenge creator will expect you to access some resource that can be read to exploit elsewhere, or you can write something to exploit elsewhere. For example, you might read in an encrypted password that's been stored improperly, or you can perhaps write to a web directory, which will allow you to spawn a web shell. There's really a lot of variations off of this. It's also entirely possible that the person who created the challenge left SMB open just for no particular reason to make you beat your head against it. So for this demo, we're going to be taking a look at Hack the Box System Nest. So we've already run an Nmap scan, and we find that the SMB ports are open. So we fire off Enum for Linux. Just to save time, I did that in advance. And we see some interesting stuff down here. We see that the server allows for a blank username and password, which is perfect. There's a lot of other good information down here, but in this particular case, on this particular challenge, the information you're looking for is up above here. So we're going to use SMB client to interact with the file system. First, we're going to just check and see what shares are available. And we can see that this data share is available right here. So let's try like so. So this prompt here is pretty similar to most other remote file access prompts you're familiar with. You can list the files that are available, and you can change directories. So in this case, since I already know what I'm looking for, I'm just going to cut right to it and go into this shared directory, then into templates, into HR. That sounds interesting. And a welcome email. Let's get that. That's interesting. I transfer the file back, exit out of the terminal, and take a look at my loot. And there I've got credentials. Now obviously this is really straightforward. Like there's nothing like this that you'd find in a real engagement, but you know, it gives you the basic point that SMB shares can be open, and these are the tools that are available for enumerating them. Of course, one of the nifty things about SMB is that systems administrators can use it to remotely administer systems in their network. The downside is that if their credentials are compromised, it provides a really easy way for attackers to move around the system. So psexec is part of the sysinternal suite, and this will allow your administrators to remotely execute commands. But it can also do things like allowing attackers to spawn netcat shells, which will give them a remote session to the system. They don't even need to compromise a Windows host or have a Windows host on the network. As long as Kali is able to tunnel into the network, psexec.py, which is part of the Impacket suite, allows the same psexec functionality from Linux. There's another tool that does something similar. Within the Pass the Hash suite, there's another tool, pth-winexe, that allows username and password to spawn commands remotely over SMB as well. Now, of course, the Pass the Hash suite can do much more than just username and password exploitation, but we'll get to that when we talk about Active Directory and the concepts of Pass the Hash in general. For now, the key idea is that any capability that you as a systems administrator have, you need to keep in mind that red teamers can use that same kind of capability to laterally move through the system if credentials are compromised. Red teamers can take advantage of the fact that SMB can be used for this named pipe communication to hide their communications within a target network. We'll talk a little bit more about this when we discuss command and control communications. However, it's important to know for now that that same name pipe capability can be abused. The basic idea, and you can see this in some tools like Cobalt Strike, where as an attacker spreads throughout the network, they'll use SMB to hide their communications within the network amongst the background traffic, and then sort of generate all that traffic into one location and use that central location to send the traffic out in a hidden manner. So in the diagram I have up on the screen, I have a topology where a central command and control daemon is running within the network that communicates with a command server on the outside via HTTPS. So from the perspective of someone watching firewalls, they just see HTTPS traffic going over the network through the firewall from a single host. And of course, this can be set up in a way that the traffic looks innocuous. Now, behind the firewall within the network, the attacker is using SMB to hide communications. So an SMB named pipe server has been set up, and all of the daemons that are operating elsewhere in the network are using SMB to communicate amongst each other, and then any instructions that are going to the outside are being aggregated by that central host. Let's see a demonstration of SMB used for communications. So one of my side projects has been developing a framework for testing different C2 communications with the goal of figuring out how to model those communications and then predict them in firewall rules and things like that. And so I'm going to be using that framework here to model this sort of communication. I'm hoping to be releasing this entire framework as open source, or at least as much of it as I responsibly can, so that other people can sort of use the framework to develop their own models. But we'll see if we get there. So first I'm going to start the server. And the server basically has little adapters that are listening for DNS emulated traffic, HTTP traffic, and native text over TCP traffic, as well as email. And so then I'm going to first fire up a server daemon, which is going to be communicating with the central command server via HTTP. And then I fire up another one, which is using SMB. So essentially what's happening is this window down here in the lower right is locally sending traffic via SMB to this daemon right here, which is then bundling that traffic into HTTP and sending it to the command and control server over here, simulating some sort of egress beyond a firewall boundary or something like that. And so you could have an entire network of these clients connected through an HTTP daemon at some place where it would make sense to have the communications tunneled outward, all communicating with the central server. So then I'm going to fire up my control unit here, where I can see that the daemon that's communicating with the central server over HTTP is available, as well as the one with SMB. So I'm going to select the SMB one. Nope, I waited too long while I was yakking. So here, really now quickly select the SMB one, and the server has allowed me control over that daemon. So now I can check what is going on here. I have full access to the shell through this tunnel, and I can tell it to go away. So it's shutting down, and the daemon is gone. So you get the basic idea is that SMB over here can be used to tunnel information here where it's bundled up into HTTP traffic, or really you could use any traffic really, to then forward that outward to a remote host. Red teamers can take advantage of a lot of things with SMB to do a lot of scary things. So let's look at the blue team side and how we can prevent those scary things from happening. While there's a lot of nuance to the scary things that can be done over SMB, on the blue team side, it's a little bit more straightforward. If you want to see the CISA guidance for how to secure SMB services, I have the URL printed on the screen, or you can Google for the latest version. The bottom line is this: you don't want to expose SMB unless it's absolutely necessary. Unfortunately, since when there is an exploit, there really isn't a whole lot you can do about it other than patch as quickly as humanly possible. One of the best things you can do to mitigate the risk is to simply not expose those services. One consideration is that SMB is really not a great thing to be using over the internet. It's really not the proper tool for sharing files over the net. There's much better solutions. That basically what you're doing is just exposing a part of your system that you don't need to. Now, even within a security enclave, where someone can't route to your SMB services from the outside, do you really need to have SMB available everywhere? Like if your host isn't serving content and if it's not receiving instructions via an approved systems administration workflow, does anybody else outside that system really need to route to those ports? And so locking things down so that only the ports are exposed that are absolutely needed for business workflows is a good way to slow things down if a day zero is launched and someone is able to get in. And also, if somebody has credentials, it slows things down a little bit more as they're less able to pivot around the network. Another good step is disabling SMB version 1. Now, this should be disabled by default on most modern hosts, but you want to double check that. The protocol is inherently insecure and just really should never be used for any reason ever. You also want to make sure that Active Directory credentials are secured to limit lateral movement, but we'll talk more about Active Directory exploitation when we do a whole unit on Active Directory. Now that we've introduced some of the basics, let's take a step back and look at another element of the big picture, specifically network architectures. We'll look at the basic topologies that you'll see with a network, and then how attackers can use those topologies to move laterally within a system. So we'll see once they have a foothold how they can move elsewhere and how the blue teamers can slow and even stop lateral progress.